Welcome back guys sa subject natin na data analysis. We'll just continue with the previous topic, previous lesson, part 1 of data analysis video lesson. So ito yung ating final lesson para sa data analysis. No? Ito yung part 2. We're going to discuss coefficient of variation and measures of concentration, also box plots, and the two types of concentration measurement, yung Lorentz curve and the Gini coefficient. So we'll start with the coefficient of variation. Ano yung definition ng coefficient variation? The coefficient variation, V, is a measure of dispersion which uses both the standard deviation and mean, and thus allow a fair comparison. Okay? Suppose we have a situation where two different variables have arithmetic means of xi and x2 with standard deviation s1 and s2 respectively. No? Suppose or we want to compare the variability of hotel prices in Munich and London. How can we provide a fair comparison? Now, we use the coefficient of variation, and the formula is V, which is stands for variation, is equal to S over X. S is the standard deviation, and the X is the arithmetic mean. No? The coefficient variation is unit-free measure of dispersion. So meaning wala tong unit, no? But we can assign a unit using the linear transformation yi equals bxi. It is possible to show that if a value is xi of a variable x, the transform into variable y with values I equals b times xi, then b is greater than 0. Then b does not change. If we can assign a unit, no, then we can also use this linear transformation. No? So if we want to compare the variability of hotel prices in two selected cities in Germany and England, for example, we could calculate the mean prices together with their standard deviation. If we have 100 hotels in Germany and England and we have the following standard deviations and mean, for the mean, we have xi 130, x2 230, so on and so forth. And then the variation we have, for the variation, we will have the 99 over 130 and also 212 over 230, which gives us the 0.92, which is higher than the value or variation of Germany. No? So this indicates higher variability of hotel prices in England. However, if the data distribution is skewed or bimodal, then it may be wise not to choose the arithmetic mean as a measure of central tendency. Likewise, the coefficient of variation. So, kung skewed daw, ibig sabihin hindi siya normally distributed, no? Medyo naka-slant sa left or right ang kanyang data sa graph, or hindi siya bell-shaped, then it is not advisable, no, na gamitin yung coefficient of variation. But anyway, this is if the data is not skewed and is normally distributed, we can use the coefficient of variation. So how to use the box plots? Ang ginagamit yung box plots at ano kanyang use, no? So far, we have described various measures of central tendency and dispersion. It can be used to list those measures in summary table. So, kung ililist daw natin yon bilang table, medyo mahirap gawin and also hindi presentable, no? Malilito yung ating audience kung hindi tayo gagamit ng proper tools, no? Proper graph para i-represent yung various data na yan, no? A simple and powerful graph is the box plot, which summarizes the distribution of a continuous or sometimes ordinary variable by using its mean, quartiles, minimum, maximum, and extreme values. And sa box plot kasi, pwede nating i-represent yung various data na to, no? Sa isang graph lang, no? Tulad nito, we can represent maximum and the minimum value. We can also show the median kung siya ba ay nasa center or skewed. We can also present or represent the groupings, no? Meron ditong third quartile, meron first quartile. Kung meron namang extreme values, pwede rin siyang gamitin. So, extreme values, yung mga outliers, no? Yung mga nasa labas na ng scope ng ating median, no? So, the boxplot command for R draws, ito yung kapag gumamit ka ng R application, boxplot variable range 1.5. After executing this command, yan, kukumputin na niya yung measurements or di-display na niya yung data using the boxplot. So, to give example, using the boxplot, consider again the feature data described in Appendix A. We use the R to plot the box plot for the delivery time. So, using the R application, it will display the following graph, no, using the box plot. So, we have the temperature for the weather data. So, makikita natin na wala siya sa center, yung kanyang median. This is the median. This is the wala siyang nakalagay na quartile and first quartile or third quartile. Wala rin siya nakalagay na maximum at minimum, no? Pero dito meron. We have maximum, minimum, and meron siyang outliers, no? And also, sa pizza data, example natin, ang kanyang median ay nasa gitna. So, this is normally distributed. No? Ibig sabihin, various data na narito, they have almost the same median. No? But dito, meron siyang medyo skewed yung kanyang center. No? Skewed yung kanyang median. Ibig sabihin, hindi yung weather data ay hindi magkakaiba, no? Magkakaiba ng average or ng distribution, no, dun sa center, no? Measurements of concentration, a completely different concept used to describe a quantitative variables, the idea of concentration. For a variable x, it summarizes the proportion of its observation with respect to the sum of all observations. So let us look at a simple example to demonstrate its usefulness. So we have an example here, merong farmland at meron tayong distribution, no, ng farmland by area in hectare. So ito yung farmer 1, farmer 2. So sa unang example, equally distributed yung land. Okay? For example, 1, 2, 3, 4, 5 farmer. Tig to 20 hectares sila, no? Pero dito sa farmer, pag-aari niya lahat, no? Ito si farmer 5. Okay? Paano natin malalaman, no? Represent yung ating concentration, no? Yung measurements of concentration with the following example na data. So number 1 is to use the Lorentz curve. The Lorentz curve is a popular method to display concentrations graphically. So ano to? So again, we have the n observations, the total observation. The xi, x2, xn are the variable x. Assume that all the observations are positive. The sum of all the observation is, so we have the summation formula. If the data is ungrouped, first we need to order the data. So isosort muna natin yon either from ascending order or descending order. No? So to plot the Lorentz curve, we need the formula U, which is the unit. And then unit I equals I over N. So siya lang yung sequence, no? Ito yon. The U represents this. Okay? And the V for the variation, we have the following data for the hectare, no? Yung kanyang data for the concentration, no? Sa distribution ng land. Okay? So notice nyo yung I dito sa unit, nagsimula sa 0, yung I dito sa portioning or doon sa hectare, no? Doon sa division mismo ng land ay nagsisimula sa 1, no? So, graphically, kung wala daw concentration, Lorentz curves for no concentration, ito yung makikita natin. And kung meron naman daw concentration, meron makikita tayong curve dito. Okay? So, ang tawag dito sa line na to is the line of equality. Ayan. Okay? So, graphing the variation and the U will give us the coordinates, no? For example, UI, VI, no? So it means that UI times 100% of the observations contain VI times 100% of the sum of all XI or observation less than or equal to I, which is the index. So para ma-absorb nyo, we will have this example, no? Where we look at the distribution of farmland among the 5 farmers. Sa U, we have 1 over 5. Sa U2, 2 over 5. So on and so forth hanggang maging 5 over 5 or 1. Sa variation naman, we have the 20 over 100. V2, we have 40 over 100 hanggang sa maging 1 si VI, which is 100 over 100. No? So for example, walang concentration, okay? Proportion yung distribution. So we will have 0.4, 0.4. So pareho sila. But kung mayroong concentration, hindi equal yung distribution ng land, then it will show a different values for U and for the V variable. Other than the Lorentz curve, we have also the Gini coefficient. Okay, so Gini coefficient is used in conjunction with the Lorentz curve. No, so the formula for the Gini coefficient is 2 times f, which is the area between the curve and the bisectional diagonal line. So after plotting the Lorentz curve, okay, parang i-overlap lang natin 'tong dalawa. Okay, sa Gini coefficient. Parang pinagsama niya lang 'yan. So, for example, no? For example, na-compute na natin, na-graph na natin yung Lorentz curve. Para makuha mo yung Gini daw, Gini coefficient. Kapag pinag-overlap natin 'tong dalawang table na 'to, yung line of equality, okay? Mapapatong, no, mag-overlap dito sa curve, no, nung merong concentration, kapag merong concentration. So yung sinasabing F, ito yun, yung sinasabing F between the curve, the area between the curve is ito, ay dito sa ito yon. Yan. Okay? Kung isa lang concentration, for example, ito lang. So, ito yon. Okay? The area. So, makikita nyo, sa F1 is half nitong box na to. Okay? So, makikita nyo, kaya siya 2 times the area. So, explain lang natin kung ano yung meaning ng formula. Meron tayong summation formula. So, gets natin yung difference. 0.5 kasi half. Kita nyo, ito yung 0.5. Ito. Yan. Itong half na to. Yan yung 0.5 na sinasabi. Si FI, di yung total concentration, no? Yung total area. Minus the half. Yan. Ito naman ay computing for the U minus 1. Ito yung series ng U, unit. And then multiplied by the variation. Also, the change in the variation divided by 2. Again, summation, you have 1 over n, the total unit. For example, kung total ng unit ay 10, so 1 over 10. And then, the change in the variation. So, let's have an example, no? So, we have a farmer, 1, 2, 3, 4, 5, 6, 7. Farmland sizes. So, may 7 farmer at ito naman yung yung kanilang distribution ng land, no? So, kung ita-table natin siya, we have the following values for U and we have the following values for V. Okay? So, ang computation ng U is for this index or for this unit, no? So, 1 over 7, the total, meaning 1 over I or I over N, no? Or x over n. So we have here 1 over 7, okay? 2 over 7, 3 over 7, so on and so forth. and then we compute the value. We get the value after completing the operation. No? And then for the V value, we use the X column. No? So 3, 9, 14, when we total this, we have 164. No? So 3 over 164 will give us 0.02. 9, this is the accumulated na, no? So 9 plus 3 equals 12 over 164 will give us 0.07. So on and so forth. Okay? So ito yung table natin. If we try to uh, do the Lorentz curve, to plot the curve, then we will have this one. No? So we have the U here, and we have the U value, and we have the V value. No? So from 0 to 1, and 0 to 1. Okay? So the Lorentz curve is displayed. Using this information, it is easy to calculate the Gini coefficient. Yan. So ito yung coefficient formula natin. Gini coefficient, G is equals 1 minus 1 over 7. And then the summation of the V values, then it will give us the Gini coefficient of 0.402. And then to standardize this, we use the following formula, n minus 1 over n, and it will give us 0.4695. Okay? So this is how we use the measurements of concentration for the Lorentz curve and the Gini coefficient. So that's it for our final lesson for data analysis.